All right, good morning, class. We are moving on with using samples to make predictions. So we did probability the other day, experimental and theoretical, and this kind of falls along the same lines. We got to collect some data, and we're going to predict what we expect to happen. So it's kind of theoretical, but based on an experiment, we make a prediction or theory. So lots of terms again today. Let's write down. We're going to write down every yellow term in our notes and what it means, okay? So a sample, okay, is a smaller group chosen from a larger group. If we live in a really big school, or you go to a really big school and you want to get kind of a consensus of what the whole student body is thinking, it wouldn't make sense to go to every student. That'd take a long time. Or we just had an election year. We're not going to take a poll of every single person in the United States of what they think on certain issues. So they do samples, okay, smaller groups, so they can kind of expand and make predictions about the bigger group, or what is called the population, which is the larger group. The best sample is an unbiased sample, all right? An unbiased sample has three things. It's representative of the large population. It's completely random how they're chosen. There's no preference. And it has to be large enough to provide accurate data, okay? So, I'm not just going to ask two people whether they like a certain school lunch in school here. I have to find a little bit bigger group, and then I can kind of apply it to the whole student body. All right. So it has to be big enough to at least make a prediction. All right. So it's three different ways we can get unbiased samples. First is just a simple random sample. Okay. You just completely randomly choose a certain number of people. No method to it at all. All right. Now maybe we want a little more specific. So for instance, a stratified random sample is dividing into a similar non-overlapping group. So that'd be like dividing you guys into grades in school and taking a sample. So 7th grade, 8th grade, 9th grade, and taking samples from those groups, okay? You still want to do completely random in there, but you broke them into subgroups that don't overlap. And the last one is called a systematic random sample. You're grabbing, like every 10th student in the lunch line, or, every 10 minutes you're going to grab a customer in a store to survey them. All right, so there's a system to how you're randomly choosing it. And then the alternative to unbiased sample is a biased sample, meaning we don't do a fair random picking of the people or the things we're sampling or surveying. All right, so we're going to favor one part, or something that could possibly favor one part. All right. So again, thinking about the election, if you take a sample of the big cities, most of the cities voted for Hillary Clinton. If you only sampled those people, then yeah, they're going to project she's going to win. So you don't want to be biased in how you pick them. So one way to be biased is a convenience sample. All right. By just grabbing, the first 10 students in line. First 10 people that walk through the door. That's just convenient. Because they're likely, they could, in a bigger setting, have all the same views. All right? And then also a voluntary response sample. These happen all the time in the school here, where, we send an email and it says, please respond, fill out the form, fill out the survey. And we only get a voice is only heard for those that respond. So it's only showing those that really care. So if a principal send out an email asking the seniors when they should have commencement, meaning graduation day, he's only going to have the opinions of those that actually care enough to respond. The ones that don't care aren't going to respond, and so you only get the sample of the voluntary group. All right, so it's not a very good picture. So let's look at some ways of identifying what's what here. Okay, determine the types of music customers like. All the people attending a concert of a country music singer are surveyed. Identify the sample as biased or unbiased and describe its type. All right. Well, what do you think? They're at a country music concert. Is it going to be biased or unbiased? Yeah, it's going to be biased. Okay, they like country music more than likely than other types if they're at that concert. Okay, and what type of sample are they doing here? It's a convenience sample. They're just grabbing the people that are at this concert. They're not making it random. They're making people at this one location. All right, it's only one location they're surveying at. So since it's biased and convenient, and I guess they put voluntary response, I just go convenience. We don't need to figure anything out because we're not going to use biased information. We want unbiased information. All right. Real world number 2. A pet store mailed a survey to the residents to determine their favorite pets. 50 people responded. The results are shown over here. How many do we expect can choose dogs as a favorite pet if the city had this many people? So if it's unbiased, we'll take the number of dogs over 50 because that's how many responded, and compare it to how many we think would be out of 1,585. But we all know, or should know, this is a biased sample. Why? Because they only got the responses from people that volunteered to do it. So it's a voluntary response. Alright, so we move all these. So it's not going to make an accurate prediction, but hypothetically, you don't have to, if it's biased, you don't have to do this. But if I wanted to make a prediction, there's 20 people that chose dogs out of 50. So 20 out of 50. And I want to know how many that would be out of 1,585. Well, we just did these last chapter also. We want to solve for that. We're going to cross, multiply, and divide to find how many. We don't need to do that though because it's biased. Alright, we don't care. If the information is biased, we don't want to know it. Alright? We don't care if it's unbiased and it's going to be helpful. Alright, last one, number 3. There's a batch of 750 computers. These are supposed to be covered up right now, but that's fine. Whatever. Every 150th chip they choose at random to check for defects, and they find 2 of them. Is the sampling method valid? Well, yes. It's the systematic random sample. They're grabbing every however many number. So there's no bias as to, choosing a group of them. They might get a group that's all defective in one set. That's why they do it in every 150, kind of spread out the data. So it's completely unbiased, it's spread out, it's fair. How many would we expect to do out of 7,500? Well, if 2 were defective, we can find out how many we actually grabbed. Alright, well, I grabbed 1 out of every 150, so I can kind of count by 150 until I get to this number. 150, then the 300th one, then the 450th. Or I can just take 7,500 and divide by 150. Okay, the choice is yours, but there would be 50, I believe, grabbed. So there's 2 defective out of the 50 they tested. So how many would we expect out of 7,500? Well, again, I'm going to cross, multiply, and divide. They have this other problem they can solve. I prefer this one. They have it over here. Cross, multiply these 2, and you're going to divide by 50. All right, and you would get an answer of 300 defective chips. Okay, so if 2 out of 50 were defective, you would expect 300 out of 7,500 to be. So we take a smaller sample and we can make it apply to a bigger number without actually having to test 7,500 of them. Alright? Saves a lot of time. We found out this election is not always accurate because there might be some bias involved. So we got to make sure they're unbiased samples, otherwise our predictions will not be accurate. Like this year's election between Clinton and Trump. Alright, that is using samples to make predictions. Have a wonderful, wonderful day.